Section 3, Video 1. Section 3 deals with factoring. So this first video is going to be a brief overview of all the possibilities, and a lot of this is review. First of all, factoring can take on many different looks. The most common type of factoring problem is to just look at the terms and see if they have anything in common, and it should always be your first line of factoring to make your problem look simpler. So a greatest common factor normally is basically labeled like this, and that would be to take something out. So if I have 2n squared plus n, I notice that they both have an n in common, so I would take an n out and I would be left with 2n plus 1. That's factored, but it's really just, or simply just taking the greatest common factor out. Another common scenario that you might see, or a special one rather, is a difference of two squares. In this case it's labeled as perfect squares. Now the key to this is remembering that you have perfect squares. So if I look at this, I see I have w squared, that can be rooted, that means it's a perfect square. I have 49, that can be rooted, so that's a perfect square. But in order for me to continue, I have to validate that yes, it is a difference of, which means subtraction, and it's something we can only do if it's subtraction. We cannot do a sum of perfect squares, only subtraction. And this is easily factored. It may look difficult, but it's actually quite straightforward. You would write the root of the first term first in each of your binomials, and you would write the root of the second term second in each binomial. And in order for you to just have two terms left when you FOIL or after you FOIL, you have to have different signs. Now it doesn't matter which one's positive or negative, they just have to be different. And if they were not different, then you would have a middle term, and that's not what we have here. So you must remember to have different signs. So a difference of perfect squares is easily factored if you notice that it is a difference of two squares, and it's pretty much when you have only two terms. Again, remember, if it's a plus sign in between, you can't do it. We also have, and I'll skip this next one here, factoring by grouping, which is creating four terms. So you can factor it by looking at two terms at a time. So you create four terms, and we'll look at that later. And then the typical trial and error, or it's also called guess and check. Now the last thing we'll look at is, in brief, is a little shortcut you can see right here. And you can look at this and use it if you like, but again, you can factor these like normal with your trial and error, whatever pattern you want to use. It just ends up with a unique answer. So for example, if we factored this, we get z first. We're looking for terms that have a product of 9 and a sum of 6. Well, that would be 3 and 3. And what's unique about this one, it has to be a positive 6, so we're going to add 3. What's unique about it is that you have the same thing written twice. So you would have, so you could write this as z plus 3 quantity squared, and it represents the same thing. So again, it's a little shortcut if you want to look at it. It's up to you if you want to make use of this, but again, I'm not going to go into great detail on it. You can ask your teachers to go further on that one if you want to, but what I want to emphasize is that this is not a difficult factoring problem, but what you get when you're done factoring is a very important result. And I say it's important because it's unique that you end up with the same thing written twice, and that allows us to do something later, which is called solve by rooting. So again, an interesting observation that the result is the same thing written twice, and we can rewrite it as one thing squared, and that will come into play at some other point later in time. And this ends the brief overview of Lesson 3, Section 3, Video 1.